All right, number 23 for the trig review, and we've got three A, B, and C on these, and we want to find the sine inverse of the sine of 2 pi over 3. So you have to have a little bit of insight into your inverse functions. So remember, these would kind of undo each other if this, as long as this is in the restricted domain of sine that we had to design in order to find the inverse function. So remember, we had to go from negative pi over 2 to pi over 2. So that was going to be in the first quadrant and the fourth quadrant for the inverse sine and the tangent. So they've got to be in the first and fourth quadrant for these to undo each other. This is not in the first or fourth quadrant. This is in the second quadrant. All right, so we can take a look at this, and there's lots of ways to do this, but I'm going to sketch it out, do it kind of maybe more direct way. So this is number 23A. So it's over here. Oh, it's kind of lousy there. And that's my 2 pi over 3, which is 120 degrees. And then this is my reference angle, which is going to be pi over 3. And 2 pi over 3 plus pi over 3 makes 3 pi over 3, so that's pi. Okay, that makes sense at 180 degrees. Okay, so this is actually going to be what we're talking about, but this, like I said, the reference angle is pi over 3. And in this quadrant, the sine is positive. So this will be the same ratio as pi over 3. Because there's my reference angle. And it's going to be positive, so it's going to be basically the same, so I can just replace it. So it's kind of an easy fix. So sine inverse of the sine of 2 pi over 3 can be replaced by sine inverse of the sine of pi over 3. Now see, this is in quadrant 2, and that won't do because we had to restrict the domain for this to for it to work. Remember when we drew our sketch over here, and this was the sine, and this was negative pi over 2, and this is pi over 2. This is how we restricted the domain. Like that. Hope you guys remember that. So you kind of have to always be aware of that. We had to restrict the domain so we'd make it a one-to-one function. So this was the sine function. Sine of x. Now, I want you to think about this so you really understand what's going on, so you'll remember it. Remember, we had to restrict this function so it'd be one-to-one, otherwise it wasn't one-to-one. So that tells me that this is the domain that this has to be in for these to undo each other. Since this is over here, minus 2 pi over 3, it's over here, it's in this second quadrant, because this is actually, actually over here. This is quadrant, actually 4, and this is quadrant 1. This is over here in quadrant 2. Between pi over 2 and pi. So it's not going to do. So we've got to be in here. So we've got to rewrite this as an equivalent angle. And since sine's positive in both these quadrants, okay, 1 and 2, I can just substitute. It's going to be the same thing. So this would be the same exact value. What's the sine of pi over 3? The sine of pi over 3 is square root of 3 over 2, and the sine of 2 pi over 3 is also square root of 3 over 2. So it's the same thing, except this is in the range. So now these will undo each other, and I have pi over 3. So that's how that simplifies. But you have to realize that's what you have to do. You have to get an equivalent value. All right? In other words, the sine of pi over 3 is the square root of 3 over 2, and the sine of 2 pi over 3 is also the square root of 3 over 2. This is what we've got, but we'll substitute with this so that this is going to be in this acceptable domain. And then we can undo it. So that's kind of the way you have to approach these. All right? You can actually check these with the calculator, which I did, so there's a way of checking these with the calculator. All right? And you'll get the same answers. But okay. But you won't have a calculator on your test, so. Okay, now number 23b. Now these we can't really check because we don't have an exact value for these, so I put one of these in here because these are the kind of the tricky ones that you need to be aware of. Okay. So is this going to be is this going to be, now remember the cosine, when we restrict the value for the cosine, the cosine's got to be between 0 and pi. Okay, that's got to be in the first or second quadrant, the way we restricted the value. And I won't go into that, but that's what we had to do when we restricted the value for the cosine. It was from 0 to pi to get it to be 1 to 1. All right, well, I guess I could do it over here, just to review it, because you should know this stuff. And the cosine started, remember the cosine started at 1, and it goes down here to -1, and this is pi over 2, and this is pi, and went like this. So in order to make it 1 to 1, we had to restrict the domain. Thus, let me pull this up a little bit. So we had to restrict it like this. So that's where we get this 0 to pi, which is actually quadrant 1 and quadrant 2. So as long as this is in these two quadrants, then it's acceptable. I can just can't, you know, these will undo each other. But this is not, because this is over here. You know, if we think about this, because 10 pi over 10 is pi. So this is 10 pi over 10, so this is going to be another 3 pi over here. Over 10. So this is another 3 pi over 10. Okay, hope you can see that. Okay. All right. I'm just going to draw it bigger. Sorry, this won't do, so you'll see what's going on, because these are a little tricky because you don't have exact values. So when I draw this over here, that's going to be 10 pi over 10, so this would be another 3 pi over 10. Now this is in the third quadrant, okay? This is in the third quadrant, and the cosine is negative in the third quadrant. All right, so I can draw an equivalent reflex reference angle up here, which is another 3 pi over 10. They're the same thing. And that's a reference angle, and these have the same ratio. See, this side's the same, and it's going to go up the same as this goes. So these would be congruent triangles. So these reference angles would be the same, and the cosine is negative in this quadrant and this quadrant, so it's going to be the same ratios. All right. In other words, this is negative over hypotenuse. This is the adjacent, negative over hypotenuse. So they're both going to be negative in both these quadrants. All right. So I need something that's going to be in one of these two quadrants. All right. So what's this angle in the second quadrant? Well, if I go all the way around here, this is going to be what? Well, that's 3 pi over 10. So in order to make 10 pi over 10, this must be 7 pi over 10. So if I look up the cosine of 7 pi over 10, that's going to have the same reference angle, 7 pi, 8, 9, 10, as 3 pi over 10. So there's the reference angle. Okay? So the cosine of 7 pi over 10 is going to actually be in the second quadrant. But it will have the same reference angle as this 3 pi over 10 in the third quadrant, which is not acceptable. So we have to rewrite this. Cosine of 7 pi. Okay? So these are going to be the same. This is the 13 pi over 10, and this is 7 pi over 10, which has a reference angle. They both have the same reference angle that the terminal side makes with the x-axis of 3 pi over 10. That's the same reference angle. Okay, everything's the same, and they're both negative in this quadrant and this quadrant, so these are equivalent. So 7 pi over 10 will be the same as 13 pi over 10. But 7 pi over 10 is in the second quadrant, so that's in my acceptable domain. So these cancel or undo each other, so I end up with 7 pi over 10. So that's how you would do it. So it's complicated, you have to think about it, but that's what's happening. Okay? And then one more, the tangent. here. 23C. And that was a tan inverse. Tan inverse of tangent of 5 pi over 6. And this is going to be good between where the tangent goes from negative pi over 2 to pi over 2. In other words, it's got to be in the, it's got to be closed like this, sorry. Okay, these are open, not closed, open. And this is going to be quadrant 4 or quadrant 1, like the sine, except it's open. They're open intervals because of the tangent. All right, it's got asymptotes there. And 5 pi over 6, if we look at this, (5 pi over 6 is over here. And tangent is going to be negative in this quadrant. I'm sorry, this is pi over 6. This is 5 pi over 6. That's my angle. This is my reference angle of pi over 6 left, because 5 pi over 6 plus pi over 6 is 6 pi over 6, which is pi. And this is going to be negative in this quadrant. Remember, all students take calculus. So tangent is negative here. So I need negative pi over 6. So it's I can either go over here, which would be positive pi over 6, give you the same ratio, or in this quadrant, and that's acceptable. So that's negative pi over 6. So that's going to be the angle that works in the fourth quadrant. These would be the same because tangent's negative in this quadrant and it's also negative in this quadrant. So that's going to give me the equivalent sine. So I can replace this tan inverse of tan negative pi over 6. And that's going to be equivalent to that. Okay? If you put both these in your calculator, you'll get the same thing. And then these will undo each other because this is in the acceptable domain, actually in the fourth quadrant. So that's going to be equal to negative pi over 6. All right? And like I said, you could put this in your calculator. Make sure you're in radians. And this in your calculator, you get the same thing. Okay? So that's 23, A, B, and C. And those are kind of complicated. You have to think about those.